This is the answer key for filling in orbitals. There's some background information on the front of the sheet, and there's also a picture. This picture is useful for figuring out what sublevels to be filling in. We're going to be working this way, starting on the bottom, working left to right. When doing this, we need to look at this table as well. This is a useful way to check your answers when you're done. It shows the outer electrons of each of these atoms. So we'll put this to the side. The other thing that you need to have is a periodic table set up for filling in orbitals. Do that by adding some information if you haven't done so already. You need to move helium for purposes of electron configurations over to the left next to hydrogen. This is called the S block, so I'm just going to label it S. Over here, we have what's called the P block. Let's label it P. Helium doesn't belong over here for this purpose. Lastly, or second to last, the D block. And then finally, the F block. Then underneath each of these blocks, we need to label them appropriately. So for the S block, we're going to label each column 1 and 2. For the P block, we will label 1 through 6. D block, we'll label 1 through 10. The F block will be labeled 1 through 14. Through 14. Now when we do these, we need to start at the top left, work left to right, top to bottom, until we get to the atom that we're interested in. And we're going to use the row number, the letter, and the columns to come up with codes. The row number is called the principal energy level. The column block that we're in will be the sublevel, and then the number of electrons will be the little numbers we wrote above each column. So for hydrogen, since that's the first box, we're stopping there, we're going to read it 1, number to the left, the block that hydrogen's in, 1. We'll write it like so, 1, S, 1. So it looks just like that. Helium is also very simple when you stop here. It has electrons that live in the 1s1 and 1s2. I don't need to write both 1s1 and 1s2, just the last number I say for a given block. So we're going to call this 1s2. This number here is telling me that hydrogen has 1 s electron, helium has 2 s electrons. So 2 electrons, 1 electron. And that makes sense because if we look at each atom, hydrogen has atomic number 1, 1 proton, 1 electron. Helium has atomic number 2, 2 electrons, 2 protons. But again, helium for our purposes, electrons belongs here. Lithium, it's right here, so I'll stop right there. Start at the top left, 1s, 1, 1s2, so 1s2. Write down that. To write down that orbital, and there's a new orbital called the 2s orbital, so 2s1. Okay, so there are 2 electrons in the 1s, and there's 1 electron in the 2s. 2 and 1 make 3. beryllium's right here. Work my way left to right, top to bottom until I get to beryllium. Start at 1s, 1 and 2. So I'll write down 1s2. So those are the 2 electrons in the 1s orbital. Can't go any farther right, so back and to the left, 2s, 1 and 2. Now I'm in beryllium square, so write down 2s2. Boron. Zoom out to see more of the periodic table as I get to boron. Boron's right here. I have to go through 1s, 1 and 2. So 1s, 1 and 2. Write that down. I can't go any further right, so back and to the left, 2s, 1 and 2. So I'm in beryllium square. I'll go all the way over to the right. I'll get to the 2p borons in 1, so I've done 2p1. Continuing on with the pattern, carbon is right here. Start at the top left, 1s, 1 and 2. Can't go any further right. So back and to the left, 2s, 1 and 2. 2s orbital has 2 electrons. I can still go right, so I'll go over and I run into 2p12. So carbon has 1s2, 2s2, 2p2. Those are the 6 electrons that carbon has. Looks like so. 1s2, 2s2, 2p2, 2, 4, 6 electrons, which makes sense because carbon has 6 electrons, atomic number 6. Nitrogen has 7 electrons. We zoom out. It's right here, so this is where we need to stop. 1s, 1 and 2. 2s, 1 and 2. I can still go further right after beryllium. I run into 2p1, 2, 3. 2, 4, 3 more makes 7. Oxygen is right here. 1s, 1, 2. 2s, 1, 2. Beryllium square. I can still go further right. 2p1, 2, 3, 4. I add up my superscripts. 2 and 2 make 4, plus 4 more make 8. Fluorine is right here. 1s, 1, 2. Helium square, back to left, 2s, 1 and 2. And beryllium square, I can still go further right, so 2p, 1, 2, 3, 4, 5, till I get to fluorine. Neon's right here. 1s, 1 and 2. Helium square, can't go any further right. 2s, 1 and 2. Cross the road. I have 2p, 1 through 6. Again, you only have to write the last electron in that specific sublevel, 2p sublevel. These are what those last few answers look like. Okay, stepping it up to magnesium. This arranged. Magnesium's right here. Start at 1s, 1 and 2. It's helium squared, can't go further right, so 2s, 1 and 2. Let's mean lithium square. 2s2, so I'm in beryllium square. Cross 2p, 1, 2, 3, 4, 5, 6, I'm in neon square. Can't go any further right, so back and to the left. Now it says 3s, 1, 2 to get to magnesium. accidentally wrote some of that in sulfur's space, so I'll just white out over that. Next one, sulfur's right here. Start at the top left, 1s, 1, 2. You'll go further right, 2s, 1, 2. You can still go right, 2p, 1, 2, 3, 4, 5, 6. Can't go further right, 3s, 1, 2. I can still travel right. Notice I'm not dipping down, just going straight across. 3p, 1, 2, 3, 4. So that was 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 4. Calcium is down a little further. Here's calcium squared. It'll be 1s2, 2s2, go straight across, 2p, 1 through 6. Can't go further right, back and to the left, 3s1, 2, all the way to the right, 3p, 1 through 6. Can't go further right, so back down to the left, 4s, 1 and 2. Down here so you can see it. 1s2, 2s2, 2p, 6, 3s2, 3p6, 4s2. If we add up all of these superscripts, they will equal 20. Two more. These add a little bit of a wrinkle here. So we're looking at iron. Iron is right here. It's in the D block. It's the first time we've had one that lives in the D block. This is where we're going to stop. I'm just going to read it left to right, top to bottom. 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6, 3s2, cross, 3p, 1, 2, 3, 4, 5, 6. Can't go further right, so back to the left, 4s, 1, 2. And if I go further right from calcium squared, it says the number 3. So I'll have to go 4s2, then 3d, 1, 2, 3, 4, 5, 6. That's 1s2, 2s2, 2p, 6, 3s2, 3p6, 4s2, 3d6. And that 3 is coming from right here. So it's 3, the bottom of 3, d6. So last one, bromine. Look at the last row here. We're going to go 4s2, 3d, there's 10, and I go one spot further, right after zinc. When I go further, it says 4p. So that'll be 1s2, 2s2, 2p6, catch you up, 3s2, 3p6, 4s2, 3d10, 4p5. The very bottom, it says if we count the highest principal energy level, the highest sets of numbers in front, that'll tell us valence electrons, which means that hydrogen has 1 valence electron, helium has 2, lithium has 1, and I'm only circling the 2s1 because the 2 is higher than 1, beryllium has 2, boron has 2 plus 1, which makes 3, carbon has 2 plus 2, which makes 4, nitrogen has 2 plus 3, which makes 5, oxygen has 2 plus 4, which makes 6. The 2 and the 2 are bigger than the 1. 2 and 2 make our valence, and 2 and 5 make 7. Neon has energy level 2, energy level 2, 2 and 6 make 8. Magnesium has energy level 3, which is higher than 1, 2, and 2. So the 3 in the front of the S gives me 2 valence electrons. Sulfur has energy levels 3s2, 3p4, 2 and 4 make 6. Where's the highest? That makes 2 valence electrons. Here's an interesting one, iron. 1, 2, 2, 3, 3, 4, 3. 4 is the highest, so it has 2 valence electrons. Bromine has 1, 2, 2, 3, 3, 4, 3, 4. So the 4s are going to get my circle. 2 and 5 make 7.